This is the easy world of science. I will be using this animation to simplify DNA replication just in few minutes. The enzymes and the proteins that are involved in the DNA replication are number 1, the helicase, then number 2, topoisomerase, number 3, the single-strand binding proteins, which are not enzymes themselves, then number 4, the primase, then number 5, the DNA polymerase 3, number 6, the DNA polymerase 1, then number 7, the DNA ligase, and number 8, the telomerase. These are the enzymes that will be used in this DNA replication. Let's go. The initiator protein binds to the origin of replication, which is free with AT junction, adenine thymine junction, then followed by the helicase unwinding the double strand by actually breaking the hydrogen bond holding it. During this process, topoisomerase prevents supercoiling, making it easier for the helicase to unwind it. The unwinding creates two single-stranded nucleotides. Then the single-strand protein binds to each of the strands to prevent them from re-annealing. Then the next is to add the primer by the primase. The primer sets the pace for DNA polymerase to start replicating the complementary strand. In the lagging strand, the complementary strand is replicated in fragments known as Okazaki fragments, which are later joined together by the DNA ligase to form a continuous strand. Then the lagging strand always have a short length. To complete this length, there is addition of telomeres by the telomerase to maintain the length of DNA and prevent genetic loss. So this concludes the DNA replication. Important notes: the DNA polymerase 3 can only replicate the complementary strand in the 5 to 3' direction, and again the proofreading is done by DNA polymerase 1, which removes the primer and also removes any mismatched nucleotide, replacing it with the correct nucleotide. Then during this process, there is also the high chance of some mistakes where these things are corrected after replication by what we call the mismatch repair system. This uses the nucleases, which we have the exonuclease and the endonucleases, cutting off the wrongly matched one that escaped the proofreading process to replace it with the right DNA nucleotide. Remember, the primers are short RNA nucleotide to set the pace for the DNA polymerase. The RNA will be removed after that. The primers will be removed and then replaced by the correct DNA nucleotide by the DNA polymerase 1. It is important to note that DNA replication is semi-conservative, meaning that each DNA molecule is composed of an old parental strand with a newly synthesized complementary strand. So no DNA molecule is entirely synthesized new. So they all arise from previously existing DNA molecule. The detailed video and explanation on DNA replication is available here on this channel, so watch that video to get more details. If this animation is of any help to you, please subscribe and share this video. I cannot do without you. Much love from me to you. Stay majestic. Bye for now.